All right, anybody online? Can you verify you can hear me?
We can hear you.
All right. When I have the screen up, is that okay? Or I'm having a lot of problems trying to get this looking cool. Like, can you see that or not?
Yeah, we can see it.
Okay. Why does it keep going back? Say something again.
Hello.
Okay, so that must have been my finger dragged. It switched pictures for me. All right. I am completely off my game right now. So this is going to be fun. We'll see what happens. We're trying a couple of things here today. The first thing is we are trying to record this so that those of you who have COVID or who tested positive for COVID or who otherwise found themselves in quarantine can actually view it now and for eternity through the miracles of YouTube. But it's for my first time in the room. I did not expect to have that up there, and that set me on a red herring, although I think if we can figure this out, this may save me bringing a lot of equipment down. By the way, for those of you online, there is a smart board on rollers in the middle of the class that has a WebEx. So that may be our way out. I've got to kind of think this through a little bit on how best to use that. All right, so today is our third week of classes. About a third of the classes, about another 2 or 3 weeks are going to be involved in this kind of philosophical or community building type of exercise. And then we're going to get into some specific tools, and we're going to kind of launch you guys off on doing your own projects. We'll couple that as we go through that. We'll do some things with like hopefully TensorFlow, although I have to see how much it's changed since last time. The beauty of this course is that it's an open source course. Almost everything I lectured you on is either open source or near open source, MongoDB being the near open source, which means that over the course of a year, it's been a year since I taught this, things can change substantially, which means that every year I have to figure out how to make the labs work. So we will see what we see. We will try to make this as good as possible, and we will soldier on. Today we're going to talk about documentation and community, and although this says documentation and community, I'm going to do it in the opposite direction. I'm going to talk about community first, and then we're going to talk about documentation, because in reality, in open source software, you're not on a project, at your company, and you've been given strict directions on what to do, and you have to get X, Y, and Z done, and that's your paycheck. Sometimes it's that, but other times it's more along the lines of you want to do something in the community, or you're working for a company who's participating in the community, and you actually have to play nice, just like being on the playground, right? If you irritate too many people, open source software, who owns open source software? Well, you have a copyright, right? Copyright is the person who actually owns it. But if they've granted you rights, and if they've granted you open source rights, that means you have the right to walk away. And as long as you abide by the licensing agreement, you can take your toys and go home and not play with them anymore. And if enough people do that, you either end up with two communities, or you end up standing alone on top of the king of the hill mound with all of your worker ants off busily making some other project better, maybe your project better. So community is really kind of key here, and a lot of the things we talk about are things, this section is really hard for me to give because there's a lot of philosophical stuff. I'm more of a technical guy, but it's also one of the more important sections of this course, because this is what you have to think about when you're building an open source community. How am I responsive to the people who are out there? How do I work work in such a way that I involve them, give them motivation, and keep them happy without ruining the project, right? Too many happy people can ruin a project too. if you're always giving in and being swayed by every which way the wind blows. Did I have you guys read the paragraph, the reading on flow yet? Okay. One of the things you're hoping for is that at least a couple of times a year, you're going to get a couple people into a flow state where they're just kind of into your project. And they'll knock out a tremendous amount of issues and a tremendous amount of, make a tremendous amount of progress. And the goal is to keep you in that flow state as well. So this is all kind of moving together. Open source software, you can't always throw more money at it. Sometimes you can. But you can't always just throw more money at it and expect that it will take care of itself. You have to concentrate on, we'll move that afterward, but I wanted to be able to see you guys over in the corner. Yeah, so you have to actually concentrate on this. So let's talk about community involvement. With any luck, we're going to get into a little bit of a mock debate. We'll see how that works at the end of this section, or maybe we'll go through the documentation and then try to wrap this up at the end of that section. But the idea of the mock debate, I guess I should probably be wearing the other mask. Isn't that what you guys have been told? Paper masks with 60 microns are better than cloth masks with 500 micron pores, something like that. All right. Part of the mock debate we want to talk about is when we get there, and so keep your eyes open and kind of think about this as we're going through the course today. Is we know how to make money off of proprietary, right? People tend to think that open source software is free as in free beer, not free as in free speech. That's not true, right? The whole idea with open source software is that this has to be a self-sustaining community, and if everybody does stuff for free, then everybody starves to death. So it's good to have this as a, if it's an avocation, if it's a hobby, that's one thing. If it's how you want to make your living, which would be great, right? Because you're using your lifetime and your resources to make the world, if you believe in open source software, to make the world a better place, right? It'd be good if you could actually survive longer than a few years on it. So the idea between open source and proprietary software is not that one can be sold, or one you can make money off of one and you can't make money off the other. It's that they have different business models and different things that they're good at. So as we're going through today, kind of think about that as well as this community building types of things. And then hopefully at the end we'll have time for a little bit of a debate between the differences of open source and closed source software or proprietary software. And then the building communities, that's some really good guidelines. I really liked this, right? I want you to read the first two briefing notes. I will say that the essential tools, I'm not seeing so many mailing lists anymore. A lot more communication is being done over GitHub or in Discord or in other channels. Mailing lists are still a really great resource because they can be a low volume way to continually track resources, and if you automatically archive them, you can always search back. If you've ever tried searching back on Slack or Mattermost or Discord, you can find that it's not really good for a Q&A type of environment. But that's the one thing that I saw in reading through this that's a little stale, is the idea of a developer mailing list. I'm seeing fewer of those, although in established projects there still are quite often mailing lists. Generally there'll be like a developer mailing list, then a user mailing list. Right now if you're on Submity, or if you've worked on Submity, which is an open source project, what you'll find out is that they have Slack channels, and the Slack channels are RPI, teaching staff, questions, developer forum. There's a number of forums divided up based on your interest. The problem is, again, that information can go stale and not be easily accessed, whereas in a mailing list you can often keep it going. All right, so I've been talking about this a little bit. There's a couple of things that are important about open source. The first thing is that open source leverages the fact that people like to be part of a community. And the whole idea is to make it so that when you're doing open source, you are feeling like part of this community. And the initiation of people into the community, you want to build up a sense of belonging and a sense of contribution. If you've ever been on like a baseball team or some sports team, and you're the person sitting on the far end of the bench, and no one wants to put you in the game, it's kind of sad, right? You don't feel as engaged. Whereas bringing people into it, helping them to participate fully, and getting them involved is a really good way to build up friendships, build up camaraderie, and overcome difficulties. So open source software tries to leverage the fact that people want to be part of a community, and it's not a sinister thing. Like, they're not going out and saying, how can we bring, well, some of them probably are. But it's not intended to be a sinister thing. You know, we're not going out and trying to brainstorm you or gamify you so that you are addicted to open source, although, you know, if you end up being addicted to open source, there are probably worse things. So that's part of what we're trying to do. One of the benefits of that is if you have a big community, if you know, and you make your code open source, the code gets looked at by a lot of people. So the code doesn't necessarily start out as higher quality, and bugs can still get in. So if you look at, what was it, log4s or something like that? Log4j. There was a pretty big bug in there that was allowing people to, you know, essentially, in a simple logging function that just recorded interactions with the system, that allowed people to actually break into your system. The key is, though, that once something's discovered, first off, there's a lot of eyes looking at it, so the chances of somebody discovering it are a lot better, right? And the second thing is that once it's discovered, people move very quickly to fix it. My wife was involved with using Log4j, and she had a very bad week about a month ago when the bugs were announced, where the security hole was announced, and everybody had to patch. And her company was scrambling to patch, and they would just get a patch out using the new Log4j software when they would find out that, no, in fact, we didn't quite fix it. Try again, right? So they went through a series of about 3 or 4 cycles of changing their Log4j, usage of Log4j to be secure. And that's irritating from a developer standpoint, but if you think about it from the consumer standpoint, almost immediately a fix came out that fixed the most pressing problems. It didn't get everything. A little later, another fix came out that took care of some more problems. They discovered something else while they were doing that because there were a lot of eyes on the project. And again, it iterated again, maybe a couple more times until they had a full solution out. But the full solution, she spent a week working on it, right? Off and on, changing their software, responding to different issues. But at the end of that, it's done, right? And a lot of that is because there are many eyes, and once attention was focused on that, once we knew where to look for the problem, you know, very quickly they iterated to a solution that seems to be sticking so far. I may never get through this slide. Anyway, different perspectives and uses of code. When you're doing code development, right? I don't know how you guys do it. You start off, you write your code works. Well, not really. You end up with a couple of errors, right? And then you fix a couple of the errors, but you learn that if you don't enter this specific input, or you do things in the correct order, things don't crash. If you do them in the incorrect order, they do crash, and then you go on for a week and you forget that you're doing things in the right order to keep it from crashing. You've developed a perspective and you've developed a workaround for software that the next person isn't going to have. So by getting many people involved, by developing a community, you're going to get people using your code in ways you don't expect. And when you use code in ways you don't expect, you find errors that you cannot find yourself because you are going down a specific path. You know what your code is intended to do, and you know how to get around the errors. What you'll also find out is that your code may be completely useless for what you intended it to be used for, in which case your project's probably going to die. Or it may, conversely, be really useful in ways you never expected, right? In which case your code will grow and maybe become log4j.s or log4j and crash everybody's systems at some point. But the idea here is that any finite developer pool or any small developer pool is going to end up with more errors in their code when they launch it. More errors and less use and possibly less useful code. Whereas if you have a big community where everybody has their own vested interests, it's not like we're cooperating to make the code better. It's that I need something, so I'm working to further my own goals, and by doing that, I make the code base better for everybody and reduce errors. And finally, a lot of people testing your code, and then there's this idea of reciprocity. If you're helping out other people, if you're part of a community, you're answering questions for people who have questions that you can answer, then you can expect in the community, as you've built up this bond, that other people will be more responsive to actually answering your questions. You guys aren't bringing tomatoes or something, right? You're not going to throw stuff at me at the Shield. Because I kind of feel like I'm in a old country and western bar with the cages up to protect the performers. So we need to build up this community. And that brings us into tools. There are 4 basic tools. Website, we're calling it a developer mailing list. I don't really care what technology you use. You need something for the developers to talk. A mailing list is good because it's archivable, it's searchable. Those are 2 characteristics you really want, archivable and searchable, because you don't want to be answering the same question every time over and over again, right? You want to answer the question once and then possibly at some point pull a fact together with all the common questions, but basically expect people who are bought into the system, who are bought in developers, to actually pay attention and follow the thread. You do need a version control system. This used to be a much more interesting field of study. We used to have RCS and CVS and Subversion and Mercurial and a number of other options for version control. I guess they are all still out there. But for right now in this class, we're going to ignore all of those and focus on Git as pretty much the only source control, and there's a good reason for it. Git is developed specifically for working in distributed groups, managing multiple branches, very easy to fork, very easy to take your code and go home if you want. So that's not nearly as interesting of a topic. It doesn't dilute the importance of version control. And then you need some sort of issue tracker. And the issue tracker is something that allows you to track both what you're working on so that the rest of the world can see what we're working on, and also get and act on in a public way that users can see any issues that users or people who find errors with your system or who want to use your system for something else. It gives you that tool, that contact back to a non-developer community that may have significant and interesting extensions to your class. Now, those are tools. Those tools should be helping you to develop your code and to build your community, right? Two parallel things you need to do. Develop code, build community. They shouldn't be, adherence to the tools shouldn't become the goal, right? So one of the let me see if I can pull something up. We will see if we can get there. There we go. So this is the Insight Journal, I think. Yes. I used to work for a company called Kitware. They'll actually be talking to Arcos today. Yeah. So Kitware was one of the groups coordinating on a number of open source projects. They still are. For one of them in particular, it was a consortium of half a dozen or a dozen different companies and different academic institutions working on something called the Insight Toolkit for registration and segmentation, or segmentation and registration. I get it backwards sometimes. And as they developed, as they got 5 or 6 years into their project, or into the open source project, they started implementing more and more tools on how you interacted with the system. And eventually, in order to get something new into the system, and it sounded like a great idea at the time, but in order to get something into the system, you had to write a journal article, publish it in the Insight Journal. It had to contain the code, right, the Git branch for the code. It had to include testing data, and then you had to go through and get reviewer approval. Except no one was actually assigned to do the review and approval. So in order to get your stuff into ITK, if you didn't have committer rights, you had to jump through these ever increasingly complex hoops. And the contributions started slowing down because the contributions were now gated by the tool, right? So you don't want to be in a situation where the tool is dictating the development, right? You need to be much more open than that. It was a really good experiment. It was a cool idea. I don't think they're using it that way anymore, although it looked like that was a new website for it, and it probably still exists in some form. All right. Here's some other things you can have. Well, communication. A lot of times, big open source projects will have even mini conferences where they try to get as many of their developers together in the same place at the same time. So you want people talking. They don't necessarily have to talk face to face, but if you can't meet face to face, a periodic call like this, a WebEx call or a conference call, is probably a good idea. Mail archives, just some way we can look back on previous answers and make sure that you haven't changed your mind on things, or you're not giving contradictory information, or where people who are new to the project can go back and recover your history so they know kind of why you're doing things and any community norms that are there. Forums, right? Forums are good places to have discussions. They're not necessarily really good at archiving or coming to specific answers, right? Because people come back and forth and there's point and counterpoint. At some point, you probably want to go back and make that finalized. Stack Overflow, a lot of the Stack exchanges are really good ways. There's places where you can actually answer questions and forward people there for facts, and it's really well archived. So if you type in something like installing GITK for Mac OS X, you will probably be referred to Stack Overflow posting, and that will help you out significantly. Blogs and syndication. Syndication is generally a feed of something like a mailing list or an RSS feed. Blogs are really good ways for actually engaging your customers or engaging your users and developers on what you're doing next. They're not really good ways to make decisions. They're not good ways to answer questions, but they're good ways to say, hey, we think we want to do this. And this is going to be a cool new feature that will get us to Mars by the year 2025. And if we do this, we think that we will all be able to retire up there with an acre of land and a potato field. Things where you want to announce stuff. And then, of course, social networking, microblogging, just different ways of communicating and making your project active. One of the things that's really disappointing is to find a really cool open source project and try to interact with it and find out that there is no activity, there's nobody blogging, there's nobody talking about it. It's not necessarily something that you want to join and believe that you're joining an active community, right? That might be more something where you want to join the community and work with and maybe preempt it, kind of like Eric Raymond did with the email client. There's a lot of different ways to do this. Most version control systems even allow you, in fact, Git requires that you give at least a subject line, what your commit was about, but you can also explain if, for example, you're designing a new feature, you can put your feature, what you're thinking, in your comment block for your commit. Or you can even have side branches or side directories within the main branch that describe your current development process, that give a roadmap for where you're going, what the actual goal of the project is, and how you plan to get there, and where help is needed. was one more I wanted to hit before management of intellectual property, but I am blanking on it. Okay, so let's talk just a little bit about intellectual property, and we'll hit this again a little bit more next week. Copyright's a cool thing. If you write something novel as in new, not novel as in fictional, if you write something novel, you have copyright to it. You don't have to do anything else. Okay? Automatically, by the act of generating a new idea, you have copyright. If you want to enforce that, then you probably want to put a copyright notice on it, right? Because otherwise, you write something, I write something, unless I can prove I wrote it first, it's up in the air and it's disputed who actually wrote it. When you're submitting code to an open source repository, the act of submitting does not necessarily remove the fact that you have copyright over the code. So oftentimes, when you submit to an open source repository, you have to, one, submit it under the same or a compatible, generally it's the same copyright, but it could be a compatible copyright, right? So not copyright, licensing, right? You own the copyright, you have the right to say how your code will be used. So the minimum bar is you have to submit your code under something that allows everybody else in that community to use it. So generally, if you're a GPL person, GPL requires that all derivative works be licensed under GPL, right? So we'll get into that a little bit more later. But the idea is, at a minimum bar, you have to license your code so others can use it. Yes, go ahead.
So basically, any massive code base that's open source has individual copyrights by hundreds of people. So the person who created it doesn't actually have copyright over the project itself.
If under the least barrier scenario, yeah. Okay. Now, that can get messy because the person who holds the copyright can change the copyright or can change the licensing, right? So let's say you and I are coordinating together and your code is under MIT and I release my code in your repository under MIT, we're all good because MIT allows anybody to change anything. But let's say we're releasing it under GPL. GPL has some requirements, has more requirements. MIT, the only thing you really have to do is say that I got this from, what's your name? Ariana. I got this from Ariana. And you would basically meet their requirements. GPL, you have to release your code under compatible license or under GPL, right? Essentially. GPL 3 would have to be released under GPL 3 or a higher version of GPL. Now you've decided you hold 99% of the code. I hold 1%, but it's an important 1%. You've decided that GPL no longer serves your purposes. You have the right to change the copyright on the 99%, but not on the 1%. Okay? So, that does make a difference. And that has happened. Initially, go ahead.
I guess if you find an open source community and you use it for your company,
Yeah.
whatever, and you start charging for profit,
Yep.
whatever, but then they change the license and your code relies on it,
Right. Well, they can't change the license retroactively. They can only change the license going forward.
Okay.
So anything you had that was licensed under the previous version remains. Okay? And that has happened. I'm trying to think of the exact community, but things were licensed under GPL 2, and GPL 3 is much clearer, much better written. Go ahead.
LLVM relicensed from BSD to Apache.
I'm sorry?
LLVM relicensed to
Okay.
Apache.
LLVM relicensed to Apache from
BSD.
BSD. Apache is a slightly more restrictive license, not terrible. That's pretty clean cut because again, BSD is a fairly permissive license. So that going from a permissive to a restrictive is much less hard than going from a restrictive to anything else. But GPL2 doesn't have a clause that says you can go to any other version of GPL. So I'm sorry, I should have looked this up before class. Didn't think I was going to say this. This is next week. But they were faced with having to track down all of the people who had contributed over time and get their permission to change it from a GPL2 to a much better GPL3. So that was a major deal, and they couldn't contact everybody, and certain portions had to be rewritten. So in order to get around that, as you're doing this and as you're growing, one of the things you want to think about is how you want to manage your intellectual property. And you'll see in a lot of open source repositories something called a contributor licensing agreement. Sometimes it's implicit. You know, when you submit your code, you are granting the owners of the repository copyright to your code. You're not losing your own copyright, but you're giving them the right as well to control the copyright. Yeah, so they can change it retroactively going forward. So anyway, that's just something you need to think about. Again, we'll probably talk about that more next week. Where am I? I am way behind. Okay, so that's when you're building an open source. You want to have some tools. Don't let the tools run the show. Figure out what you want to accomplish, and then choose the tools that help you do that efficiently. And choose the tools that your community likes. Right? If everybody wants to program in Vue, and you want to do it in raw PHP or HTML, you know, choose the right tools. It makes things easier and helps build community. If you want to participate, play to your strengths, okay? And this is something that, you know, if you're going to go into Arcos, how many of you are CS majors? How many of you are not CS majors? Okay, so you have a different outlook at how things go. You may have different strengths. I always like when we get a few Haas people. You're not Haas, are you? We've had some really cool Haas projects because the Haas people have way different insights into things. Our UIs end up being better, right? Our user interfaces. Our project flow ends up being better, right? How you get from one step to another. Things tend to hold together better. But, you know, if you are caught in there, you guys are all, you know, you're at a technical school, you have technical chops, right? But if you don't, or if you're just getting started out, there are a lot of ways to contribute, and it turns out that most of the people participating are going to be like you. They're going to have good technical chops. If you have other abilities, you can very quickly, right? Translators, if you can speak multiple languages and you have a project that is used in multiple countries, primo, right? Spend some time translating documentation, spend some time helping out with their user interfaces. If you know how to get people talking, if you want to run a forum, that's great. If you want to write blogs, that's great. Documentation writers, nobody likes writing documentation. If you like writing documentation or don't mind it, you can get a lot of commits very quickly on a lot of projects. A few semesters ago, when I taught this, I told the class that if anybody got a commit into the Linux kernel, that I would give them an A, and a guy got 2 commits by doing documentation changes. He got an A. He didn't actually need me to give him the A, which was good, but he would have gotten it anyway. I would have stood by it. I'm more careful now. A big thing, you know, is estimating your time commitment. Don't sign up to do a major rewrite on a critical piece of hardware during finals week, or a critical piece of software during finals week. Right? Know your time commitments. Know the amount of time you can spend on something, and make sure that when you're contributing, when you're talking to the community and telling them what you're going to work on, that you don't overcommit yourself, because there's nothing worse than having a project held up by somebody who overpromised. Right? We're all good to go, except the red button's still blue. You know, and we're waiting on you to get it done. Show your enthusiasm is a big thing. You know, people like people who engage. One of my friends, one of the guys, Luis Sabonius, you've seen his name at the start of these things. He was awesome at taking people who were on the verge of starting a flame war because of something they hated about our systems, and turning him into a contributor, because his concept was, if they're that angry about something, then it's important to them. So what better person to have working on that than the person who is angry enough to be on the verge of a flame war, right? So instead of starting a flame war, reach out and get them involved. Don't start a flame war, but do show your enthusiasm. right? If you're really interested in something, communicating, posting to the posting issues, fixing bugs, fixing minor typos, all the things that show that you're engaged are really good ways to get the community to both adopt you and give you greater privileges in the community. The last one is check your employment contract. I think places like Apple own you. If you work for them, yep.
What does RPI own? Because I know that like they have a clause that says anything we create, they like kind of own.
Yep. So that is beyond my law background, which is non existent. But my understanding is RPI will try to assert, can try to assert ownership. It doesn't usually happen, but they can try to assert ownership over projects you do using their equipment or under their pay. Okay? If you do something for class, there have actually been some lawsuits that suggest you own the stuff you do in answer to classwork prompts. Okay, so there have been at least some court cases that suggest that if you're doing work like that required for your education because you paid money for the education, not them paying you to do the work, that you own the copyright for that. I wouldn't want to litigate it, but which is why this is a cheat. Just so you all know, RPI allows us to put out code open source. If you put out code open source and you put it out under the right license, it doesn't matter who owns the copyright. Right? And it's kind of a backdoor. So do you have a question?
I'll say, so like if you release something under GPL, you can just trivially copy it and now it's yours.
Right, or if you release it under MIT, you can pull it out, no restrictions, and then reissue it under GPL after you graduate and build off it to make a new business plan. So, it's kind of a cheat, but RPI does allow us to do this course. They do allow us to require things to be released open source. So one of the benefits of that is you can get around any, most presumptions of copyright if the code is released correctly and you abide by the licensing on it. All right? So don't tell the lawyers. Oh man, I'm never gonna make it through today. The administration, I'm trying to think of the exact office. Barb Cutler runs Sabonius. I don't know if you guys knew that. Sabonius is open source. It's actually worked on under Arcos. I think some people here have actually worked on it. She was presenting to the provost. That's who it was, and about how it was and how it's open source and everything like that. And he was aghast that she was actually giving away software for free. And she was so proud that people were taking up the code and not giving her money and using it, and she was answering their questions. So I'm not sure they really understood what they were doing at the time they did it, but too late. The other thing is every community is a little different, and sometimes your comfort or your ability to interact with the community just fully depends upon the way the community operates. You'll hear things like Linus Torvalds is a really bad guy, or you may hear that he's a really nice guy. And it kind of depends upon your perspective and what you're looking for out of the community, right? So if you're a good fit for the community, you're going to enjoy doing it a lot more. If you're not a good fit, then start your own or steal the code under the appropriate licensing and go out and build your own community. There are a lot of ways around it. There's no real reason to stay in a community that's toxic. If you're in that community, you don't have to put up with that. There are, outside of legal options, you can shuffle off and bring the code with you. So that means that from the community standpoint, allowing toxicity to grow and develop is a really bad idea, right? Because you get enough people feeling that you're toxic, and all you've done is created an avenue or created a forcing function to move people out of your community and into a different community. So, kind of be aware of that, both from the standpoint of joining a community. Don't join something that's toxic. No matter how cool the technology is, unless you have a reason, a really compelling reason to want to work on that specific project, why put yourself through that? Find a group of people that you can work with, understand how they're governed. You're putting your code out there. Your code isn't going to be perfect. You are going to get criticism no matter what community you're in. Make sure when you're giving criticism, make sure you're doing it constructively, not destructively. So be careful with the way you phrase things, and understand how the people talk, because every community is going to have their own kind of how they actually operate. A couple big ones. We had a project a few semesters back in Arcos, the League of Extraordinary VTT Developers. It's Dungeons and Dragons interface on the computer, so you don't have to actually even get out of your room or see people to play Dungeons and Dragons. But they were they were under the mentorship of a developer in that community. They picked a project that was largely dead, hadn't been worked on for 6 months. There were a bunch of outstanding issues, and no one communicated or coordinated with the person with the primary developer for the project, the sub part of the project, and 3 weeks after they got started, he went on an all-night binge and cleaned up all the issues they were working on. Right, so all of a sudden they were left having to, at 3 weeks into the semester, having to completely reformulate their plan, which it worked out fine. They did very well. They did a good job. But if you need to communicate, most of the time it'll keep that from happening. Sometimes it won't. It's kind of hard to tell a guy you can't stay up all night working on these problems if they are the primary developers. Always acknowledge resources. If you've seen any of the flame wars among the comedians, right? Like Carlos Mencia is now persona non grata because a number of people have accused him of stealing their work. So you won't see. There used to be From the Mind of Mencia. Make sure you acknowledge other people. Even if you over-acknowledge people, you don't get hurt that way. But it's good to give back. There's nothing people hate more than you taking credit for their work. And you guys should have gotten that from the Eric, from the Raymond paper. If you're gonna leave, don't leave everybody. You're always able to just cut your ties and walk away, but don't do it. It leaves people feeling irritated and doesn't actually help very much. All right. Okay, we're okay. Yeah, we should be okay. None of you are going to start out at this place unless you pick up an existing open source project. And it's not always clear exactly how you get from a small boutique project to a sustainable project. But it's clear in general that a small group of people is a good way to start. People who work closely together, who can coordinate, who can set up a framework. You want something people can look at and run and hopefully modify as a starting point for any open source project. So your first thing should be, how do I get this to a form where it's usable? It doesn't have to be good, it doesn't have to be error-free, it has to solve an important problem, and it has to be usable, or be an interesting game or an interesting concept. If you get to that point, then you can start thinking about sustainability, right? Once other people can download your code and can run it and can use it, then they can start contributing and hanging, technologies off it that use it to do what they're trying to do. Okay, so there is sustainability levels, right? If you have a project that's successful, that's used a lot of places, this is kind of the kitware model. You can sell support, you can sell training, You can customize for other people. We used to do a lot of work with drug companies, trying to characterize the extent of brain tumors, glioblastomas, because they were marketing drugs to shrink tumors. They wanted to use our tools. They were doctors and clinicians and chemists. They were not software developers. So they would pay us to write customized applications for them to go in and look at the types of anatomies or the types of pathologies that they were interested in. Hardware companies, they need drivers. They really like, when they release hardware, to have drivers for as many systems as possible, right? Because that's more things they can sell into. Software companies use open source components. A lot of times, if you're working for a company like that, you are allowed to contribute back some of your time to actually making the tools better. Or if you fix a bug, you can contribute it back. That's one of the ways of participating. Some software companies actually pay their people to work on open source projects that they consider critical. Generally, those are open source projects that they have some kind of control in. Control coming from, if you have 90 people working on it and Intel has 10, you exert a lot of control over that project. So by contributing, they can help guide the direction. Not nearly as sinister as it sounds. And then there are some dual licensing models. Qt, for example, has a dual licensing model where you can do so much under the GPL, or if you don't want to release your code publicly, then you can get rid of the GPL. They'll give you an unencumbered version, just as long as you pay them enough money for it. But you're welcome to release your code under the GPL and use it. And then there are some nonprofits that actually go through and will actually help sustain certain projects. This is a few of them. We've dealt with the Free Software Foundation. That's the one started by Richard Stallman. Eclipse, GNOME, Mozilla. Mozilla used to have an open source clubs for students. I think that's kind of died at this point, but we actually hosted a group meet here a few summers back. Python Foundation for Python, Linux Foundation for Linux. All of these actually contribute money and or help out open source, development open source. I'm going to come back to this at the end. I want to make sure we get through the next part, which is we will go through hopefully a little more quickly than this. Any questions about building community? The readings in this one, by the way, are really good. They're not very long. I would expect that some of that's going to find its way onto your test, which is coming up fairly soon, not too soon. And we'll also start working on. It's also helpful when you're looking at your analysis paper, which will kind of guide you on how to get started. Come on. Yes.
I looked into how RPI deals with intellectual property and stuff like that.
Mm-hmm.
And so basically it says Rensselaer owns inventions developed by faculty, staff, students, and fellows of Rensselaer whose conception, creation, development, or first production of practice involves significant use of Rensselaer support. And basically significant
Okay.
use of Rensselaer support is...
That's the face that I made.
What the hell is supported? I pay for it. They're not like.
So significant, I looked that up. So
Yeah.
significant use of Rensselaer support is any use of Rensselaer personnel and facilities, including but not limited to space, funds, equipment, facilities, or services, employed on the job time, laboratories, computers, software, paid student time.
That's the most vague thing I've ever heard.
And so basically the only exceptions are office, residential hall, incubator or library facilities, internet access, data storage, and office computers.
Okay.
So basically, if you use RPI software, to make something, they own it.
Yeah, but if I use an RPI teacher to help me solve a problem for a
Then
class.
they own the teacher.
But for a class that I'm paying for,
No, that's use of
that's use of
personnel.
Rensselaer personnel.
So-
On our computer.
Yeah.
Yeah, you use it. Yeah.
Information using the computer there.
And if you look at your employment contract, when you get a job, a lot of these same things come out. So you do want to be careful. Again, open source is a way around that. They do allow us to release this stuff open source, and some of that has been litigated. There are actually court cases about coursework, you know, because there were people giving out homeworks and then using the homeworks in business. You know, write this part of my. I do research and I have a side company and I need this code written. So write this part of the code for me, and then I'll take it and use it for free because it was the answer to a. Well, that was an RTI.
Yeah.
That was, I think it might have been.
So what RTI wants you to do is, they want you to talk to their intellectual property office, and then they'll transfer the rights to you, maybe.
Right. Unless they think, yeah.
Unless they think that it's worth something,
Yeah.
probably.
But like at the beginning of the semester, we had to read like a chapter on like this kid who like messed up
Yep,
by accidentally fixing something.
Yep.
But technically, he did that for RPI on RPI's resources.
Right.
So didn't RPI own the copyright for that? Which meant he wasn't in violation against teachers.
He's the one who.
Yeah, so
Okay.
that's an interesting, that's an interesting take. That would have been an interesting thing to have him argue in
The
court.
thing is, this policy was, from 2007.
Yeah, maybe they have
Or
rules to
it's
protect
instituted
it.
2007, so I don't know about that.
They probably do have rules protecting themselves, that would be something different. But yeah, that's a very interesting point.
I was actually wondering if it's, this is maybe a hopeful look at it, but maybe it's in place so that it protects students from persecution like that?
Possibly, you know, I didn't write it, so I don't know exactly what it is, but it is an interesting, yes, go ahead.
What's the rules about like submitting like only for projects that we do, if we can complete one of the free technical education, would that like still go under use of archive personnel?
It's like in data structures in CS1, they tell us you can't post any of your work on GitHub because like you'll get.
That's academic integrity.
That's an academic integrity thing, yeah.
Because of the academic integrity?
Yeah,
So like, if you not like own that work, like how does that work?
right, you do own that work. Giving it to somebody else or allowing somebody else who's in the course to take it is the academic integrity part.
Okay.
Okay, and, you know, in all honesty, once you're out of the course, and specifically once you graduate, there's nothing stopping that from happening. But you know, the further you get away from the course, the less leverage they have over you for that. We've had people do it, you know, I teach CS1, so we've had people do it after the semester, and there's not really much we can do, because it's still the requirement of the people in the class not to find the code and use it.
It says RTI eventually retains full ownership rights to all the stuff that was made with significant
Yeah,
support.
yep, that's their claim, that can't be litigated. Yes?
So let's say 5 years from now, I'm already graduated and already, I can post all my homeworks on GitHub.
Yes, please don't.
Here's the fun part, you can post all the parts of the homework that you did, but any provided code from your teacher, or
Right.
any of the write-ups on like what the project was about, would have to be completely rewritten, because that's not yours, that's the teacher's
That's true,
copyright.
that's true, yeah. Yeah, but yes, you know,
I didn't keep any of my notes, don't worry.
it's just writing homeworks. If you guys think doing a homework is long, writing it is about twice as long. I can do my own homeworks in a fraction of the time it takes you, because it's my homework. But getting to that point, takes a long time, which is why we don't change them every year. We do try to keep them fresh. All right. Unfortunately, this is turning into an interesting talk, but that's okay. We can go fairly quickly through this. This last section, these are all things you should know extensively. You should be able to do all of these. Actually, you should be able to, you should know at least some of these. These are references, right? So Markdown is a language. It's really good for quick writing up some documents. And restructured text is like it. It's just a little bit different. The cool thing is something like restructured text is how most of the course notes for this class are written, and all of the course notes for CS1 are written. And you can pipe those into something called Sphinx and immediately get out something like a PDF. I use a LaTeX engine to drive it into a PDF. So you can get some very nicely formatted documents or web pages. It becomes, if you notice in like CS1, I think data structures as well, we have the web page, that's the document, but we also have a PDF of it. And that's because we're doing it in restructured text and using Sphinx to actually generate the different HTML or LaTeX that go into it. So these are really good things. The other thing that's important about these is that they are natively rendered by GitHub. So you can come in here, and if we look at what that actually looks like, right, that's what it looks like. That is Markdown, I think. Yes, there's not much different between that and restructured text sometimes. But you can write that, and then when you're on your web page, it looks like this. It looked like that up until I hit it too many times. Okay, it looks like this, right? So it renders, GitHub has a nice rendering engine for doing it. Now, I hate Markdown. I'm not all that big of a fan of restructured text. But if I'm putting something on the web that I want you guys to be able to read, like the labs, right, you can't really get much better than that because you don't even have to clone the repository in order to get to it. If it's written in HTML, which these notes are, a couple more are, not too many more, then you actually have to download it and use a separate engine to render it, right, a browser. So Markdown, and if you're doing online documentation, if you're doing users guides, if you're doing contribution guidelines, including something like an MLA agreement that when I give you my code, we share copyright. If you're doing a contributors agreement, if we're doing that, writing it in Markdown means that people can browse your repository without having to clone it and can actually see the information. So it's a really good shortcut for, come on. All right, so apparently that's not where I was. Here we are. A very good shortcut, very good easy way to write documentation that, one, you can actually use and run through something like a Sphinx to get a really high, really well laid out document, but you can also do it right on the web. You can do things in www, World Wide Web. Here's a little CSS tutorial that allows you to make really cool web pages. And if you want, GitHub actually has, come on, go back for me. GitHub actually has right, you can actually build a wiki or you can build a web page as well. The web page has to be static. I'm not finding I'm not going to spend the time looking for it. But I've created web pages for my projects before. So you can do a simple web page. If you want to, then you probably want to know a little bit about HTML. LaTeX, if you're doing anything scientific and you need equations, LaTeX is the place to be. It was written by Daniel Knuth. It's completely open source. I guess Markdown and Restructured Text are as well. But it allows you to do things like very easily, well, without too much awful stuff, render equations and format your papers. Most conferences have have a LaTeX template that you can use. And if you want to do your thesis or your graduate work, use LaTeX. There will be a LaTeX option and a Word option. Do not use the Word option. It's horrible. Learn LaTeX. It's worth the energy. Yes?
In Markdown, you can also render it now.
Yes. Yeah. Yeah. Well, that's and that's how we can translate from Markdown to LaTeX, because you can do. But LaTeX does a better job of setting it natively then. Yes.
Markdown is like .md, right?
Yeah. .md would be a Markdown file in general. .rst would be a restructured text. Restructured text. .tech would be HTML would be a www. Anyway, yeah. So we'll go through a lot of these. LaTeX is a little harder to learn, and in general, you're going to want to run it through a pre-processing engine. You know, on Windows, you're going to want to use probably MikTeX. It's built into Linux, I believe. Mac, you're going to want to use Text Studio probably. All of those allow you to take the raw format and turn it into a PDF or something cool. Or you can use Overleaf. Or when we clicked on the other thing, there was a AOR, whatever I went to on the last one, also allows you to it'll teach you, but it'll also allow you to type something in and render it online. So, for example, here is a document that I hope you guys have access to, but if not, I will try again. That just kind of goes through and shows you some of the things, right? It's a kind of a Markdown language. It's not quite HTML. Right, you can create tables. Table is there. Right, there's a table. You can do pictures. Even if it's a frog. Anyway, there's it's a fairly powerful language. It's been around since the 80s. It's still widely used in most publications. And certainly I recommend it, but I just don't like Word. And then two kind of literate programming kind of paradigms. If you're doing something in R, and we'll go into R a little bit, there's a way to combine R and Markdown that allows you to do essentially a literate document. You can put in formulas and results, but you can also put down descriptions of it, so you can have an entire file that kind of tells what you're trying to do, along with the code you wrote to do it. And that's the same kind of idea in this literate programming thing, where you can write code essentially as comments, and then write comments that essentially form a document, and then pull out actual running code snippets that allow you to actually illustrate or implement what it was you were talking about. The problem with this is really cumbersome. Literate programming, if you want to program, you don't want to do literate programming, because you're spending most of your time describing stuff. But if you're trying to teach something, this is a really good tool. Or if you're trying to document something for posterity, it's a really good tool. We've had some Arcos projects that have used Python notebooks, Jupyter notebooks, to do some really cool studies of machine learning. It's really big in the machine learning community, where you describe what you're going to do, and then you do it, and then you do it again, and hopefully you cast the results, because it took you 2 days to generate the data. But those are just some basic tools. You want to remember that documentation is there for two reasons. The first is the tools, or the first is the reason we want to do it, right? The purpose. We don't write documentation just to write documentation, but we do write documentation in order to allow people to fast follow in our footsteps. On an open source, if you're the intrepid explorer and you're doing something for the first time, your errors are as important as your successes. And I think that's something that people fail to document. If you're trying to install, for example, a big project, let's say shuttle tracker, before it got refactored, or yes before it got refactored, right? That used to be a trial and error that took 3 weeks, right? And we did it over and over again every semester. Documenting those paths and making it easier for somebody to follow with, for example, a literate programming implementation or a Docker environment actually speeds up development, right? If we're bringing in 10 new people every semester, and every semester they're spending 4 weeks coming up to speed and just getting the tools installed, that's 40 weeks a semester we're losing, right? If we can knock that down to 1 week per person, right now we've gained back 30 weeks. So it really does impact development. The other thing is the tools you use. Pick your purpose, pick the tools that match your purpose. Don't pick the tools and then try to fit a purpose into them. A number of different things you might want to do. High-level design documents. None of you are going to put high-level design documents in your projects. Guaranteed. Well, maybe a couple of you will now, right? If you want a sustainable project, having them there provides a roadmap for the next people to come aboard, or a roadmap for you to come aboard after you've spent the entire summer out on the beach, playing Frisbee and dancing in the waves. You've got to come back and remember stuff. So the design documents are actually important. We have module level documents that say what each thing you're trying to do is, right? So you should have top level documentation that says what the whole thing is for. Each little piece should have its documentation. And then as you kind of drill down and get more specific, you don't have to document every line of code. What you want to document is what you're trying to do. The code speaks for itself. If what you're trying to do is not what the code does, one of them is wrong, and that can help. Here's where we also run into issues. A lot of people like to write their documentation separate from their project, right? That's why I actually, I don't like writing in Markdown. I like writing in other things. But Markdown can live right in your code. So I have a dishwasher. Well, my family has a dishwasher. A few weeks ago, something broke, and I had to fix it. The documentation, I still don't know where that is. Right? If it had been engraved on the side of the dishwasher, I would have been fine. Engrave your instructions on the side of the dishwasher. Right? Put it in with the code. If it's in with the code, it's never lost. So if you have the code, you know how to use it, and you know how to use it, you have the code. So make it as close to the project as possible. Don't put it in a format that you don't have a reader for or that you need a special reader for, because those get old and die. Markdown is a text-based language. If you have to read it, you can read it without a Markdown engine. Right? It's just text, just annotated text. Even LaTeX, to a certain extent, allows you to do that. So specifically avoid binary formats. Avoid something that's a source code format, because you may be able to find a translator, but you don't want to have to pay for an archaic tool that's no longer widely available. Any questions? Any thoughts? Nothing. You guys were all worried about RPI stealing your code, and we have nothing on tools. Yes?
So the high-level design document, what does that look like? If you could give like a short example or something.
I don't have one prepared, but let me go off on a thought experiment. If you're designing a website, right, a good high-level design document would be what they call a wireframe. Show me the screens you have, document where the buttons are or what you're trying to do, maybe a little narrative. A little pictorial, even in pen and paper, kind of drawing, is a good way to describe what it is you're trying to do at a level that can be communicated to a broader community and kind of let your users or your co-developers know where it is you're heading and keep track of what's been done and what hasn't been done. Yes?
When you said where you're heading, I guess how do you document where you're heading, where you'd like to head? What does that include, I guess?
So what I like to use, so this gets back to the, so a diagram, things that have to be implemented are good. You can open issues that describe, you can have issues that are bugs, you can have issues that are features, you can have issues that are nice to haves. You can kind of prioritize those or be more vague or more grandiose depending upon what it's actually doing. Are you actively implementing it, or is it something you think would be a cool feature later? But the other thing you can do is I like to document use cases. So what I like to do is I like to say, a user walks into a room and sits down in front of the computer. This is the problem they're trying to solve. These are the steps they're going to want to go through to do it. And just lay that out for 2 or 3 or 4 different users, right? You might have a user, you may have an administrator, you may have, different topics they're trying to do. And these just little thread cases. This is what I'm trying to accomplish. This is how I think our system should do it. At the very highest level, they can help you formulate really quickly what needs to be done, right? So you don't go off building something that you don't need when what you actually need is really simple. At the start of any project, one of the hardest things to do is to figure out what you're not going to do first, right? Everything wants to be done first. These use cases can help clarify it. What is the first thing you need to do, right? If you're using a database, a client-server type of operation, well, maybe you can mock up, or maybe you can hand enter the data for the first 15 people. So you don't actually need an administrative interface to put those in, right, when you're small. So the first thing you may need to do is something to engage the user. And then as you get further on, then you take these use cases and you refine them and add more of the technology that you're going to use. Okay? That's kind of my favorite way to do design. It's not everybody's favorite. The software, the SD&D is a good course to get to. But anything that you can generate as SD&D can be an artifact in one of these documents, right? They can be put in your repository if you do them in the right format. So those all become good references. How many of you like sitting down and changing versions of the latest JavaScript module? You like sitting down there and just going through?
I love updating, seriously.
You
I
do?
actually think that's
Okay, you are an exception. Most people don't like to go back and redo their old code. So you want to make your code easy to maintain, right? So as you're developing, particularly if you're developing in an open group, you need to make sure that you're kind of thinking about ease of maintenance, ease of use of code, right? You want to encourage people to adopt your code. It's okay if they have problems after they've adopted it, but you want them to be able to, nobody likes to spend a week trying to install a piece of software to use unsuccessfully. So there are some big open source projects like OpenMRI and Heroku that are notoriously hard to install. And we've never used them in this course because they're notoriously hard to install and you waste too much time and you get discouraged and not fun. Do you have a question?
Well, I guess I was also wondering, does documentation include the practices that you guys use? So I know that last class we were talking about bus repositories and other
Yep.
stuff, and how to get commit in. Would you
Yeah.
also have to describe that in?
Yeah, so contribution guidelines would be part of the documentation for the project. It wouldn't necessarily be part of the documentation for the code, but yeah, and that would probably live right in the top level directory. It would probably be called something like contribution guidelines.
So you'd have separate project and code, product,
Yeah.
documentation.
Oh, I mean, but put them in the same repository. It doesn't have to be a separate repository, but kind of organized. A lot of times it's right at the top. The code of conduct, contribution guidelines, how to get started are all right at the top. And remember that if you want entry people to enter, you need something for them to do. So I know it sounds counterintuitive and stupid, but if you have a few niggling little bugs that are fairly easy to fix, and you can do it, it's often better to document it in your issues and let somebody else fix it. While you concentrate on the stuff that's maybe a little harder and a little more core. And there are all sorts of it. Again, try to make it live as close to the project as possible. You can do a blog, I think from GitHub, I'm not sure about that. Definitely you can do a wiki. Manuals and program documentation can sit there. README files can be right in your repository. Okay. Where are we? I want to save enough time to do this. I think I'm going to at least pause right there with the in-class exercises. The rest of this runs through using a number of these different tools to do something. But I think we're gonna, at least, like I said, we have about a half an hour left. We're gonna pause here, and we're gonna break up into groups. I wanna go back to the other thing, and I wanna do a little bit of a discussion for them. How many of you have ever participated in a debate? Debate? Both my sons did public forum, or one's still doing public forum debating in high school. So I got hauled in as judge often. So now I still end up going to states every now and then because I'm qualified. So important safety clue. If you have kids and they say, hey Dad, we have an emergency this Saturday, could you come and judge a debate? The answer is no, I have to stay home and do something. Because once you get roped in, you end up having to do it all the time. But what we're going to do is I think we're going to write, let's see, how many people do we have online? So, you guys online, why don't you divide up into 2 and 2 and go into our Discord? And one side is going to be, so that the premise, the proposition is going to be, on balance, open source software is of higher value than closed source or proprietary software. Okay? So it's a pretty broad topic. And it's going to encapsulate a lot of different things. Right? You can think about public good. You can think about better code. You can think about advancement of science. You can think about people surviving and paying their bills and being able to go to the grocery store. You can think about security, either by obscurity or by openness, right? So just divide up into groups. Let's say you four and you four in the back. You are pro. You four are pro. You guys are con. Right? The proposition is on balance. Open source software. On balance means by a preponderance of the evidence, or there's more evidence for than against. Open source software is of higher value than closed source software. That's what I said before, right? Okay. Hopefully that will keep saying that. All right? You guys are pro. You four are con. You're going to debate these two. We're going to take 10 minutes, kind of formulate your arguments, and then we're going to talk. Peter, Jeremy, are you guys here? Sure. Yeah. Peter, are you? Okay, we don't have Peter. So you can kind of walk around and help out. I want to make sure I didn't. Okay, you four are pro. You four are con. Okay. So we're arguing. You're arguing against the proposition. You are arguing for proprietary. Yeah. Okay. Or for equivalence. Equivalence is a valid argument against on balance. Okay. You four are for. You four are con. That leaves me with 3 of you. No, 2 of you. You join this side, and you join from that side. Yep. Work. That side is con. You guys can all come together against the problem. Well, I was too, because I don't see that I have only ever been. Yeah. So what we're going to do is we're going to talk for about 10 minutes amongst ourselves. Then I'm going to run a little round. I don't know how I'll do it. Probably a public forum kind of round where you should expect to have one person stand up and make your point. The other side, pro will make the first point. Con will make their point. Pro will rebut con. Con will rebut pro's rebuttal. And we'll throw in some discussion rounds where you can ask each other questions. All right.
Jeremy's. What was it? Did he want a pull request? Group.
When was it?
That was the thing we were talking about yesterday.
Oh, yeah, I got that. Yeah. Oh, I'm sorry, yeah. The other Jeremy. Jeremy Max requested to have Jeremy's. Yeah.
I realized just off of names it was a serious
Yeah.
problem because.
Well, I was trying to figure out. Yeah. It's like, well, Jeremy, why are you asking me? The whole thing was, yeah. But yeah, I got that solved.
Yeah, I'm glad to hear it.
Good. So this could actually.
It's nice to actually class.
Yeah.
Not too. You have much more energy in person.
I enjoy it much
Sure
more.
you're aware.
Yeah. All right, so you guys aren't going to be able to have as engaging of a debate because you're online. But what we want you to look at is, and by the way, there is no right answer for this. That's the beauty about debates. Look at how you make money off of software. Look at how you advance knowledge. Look at how you disseminate knowledge. Look at how you, the social aspects of open and proprietary software, and just come up with arguments about why your way is better than the other way. And if you just type everything, I'm not going to hold you guys to a format, but if you guys just kind of have a little bit of a discussion, take 10 minutes to kind of build up some thoughts, and then have a little bit of a discussion. Pro gives the first statement, and then con answers it, and then so it goes back and forth a couple of rounds. Like I said, I'm not going to hold you guys to a specific format, but if you can just kind of discuss a little bit, some of your thoughts and some of the criteria that would go into making this evaluation, it would be good to start considering that. Does that make sense?
Yeah, sounds good.
Okay, cool. And this is how it would normally be run. The speeches and time limits. We will modify that a bit for here, but you guys can just kind of go back and forth and kind of discuss some ideas. That's just as valuable. All right? All right, got about 20 minutes. So you can see that this adds up to 8. This adds up to significantly more than that. So we're going to cut this, we're going to make this quick. You are all matched up against another team. Pro's going to go first. They're going to stand up. They're going to talk to your team. You don't have to stand up, but get close enough so you can talk to the other team and make an up to 2-minute statement for why our premise is correct. On balance, open source software is of higher value than closed source software. Okay? So Pro will go first. Con will then answer with a 2-minute rebuttal. We're not going to do crossfires. Crossfires are gotcha moments where you try to trick your opponents into saying something stupid. They often work. That's correct, right? You guys are good debate. None of you. I thought. Somebody in my classroom. Gotcha. Okay, yeah. So why don't you guys get going now? I'll time it up to 2 minutes. Well, 2 minutes once I get the stopwatch or the timer going. All right. Yep.
Furthermore, for example, Linux is pretty much a server software, and we're also just a lot. And version control is a lot more. Make your own software, build software, a lot more. And specific version of the external OS itself. Not a personal simple so like companies like Microsoft is going to sell project itself now. So it kind of allows companies like security to collaborate or and multiple works for Linux, Windows, Mac, any operating system. So it allows for
All right, in 2 minutes. Now, Con, these guys are idiots. They don't know anything, right? Sure, prove to them they're wrong. You got 2 minutes. Or actually, you can state your own case. Yeah, prove to them they're wrong. State your own case. What? For right now, make your own case. If there's something they said is complete, I'm not going to do flow through and everything like that. I'm gonna. Okay. Yeah. But there are specific notes. All right, get started.
Well, it does have the ability of a lot of different ideas. Those ideas are also, but these things that are unbeneficial to them. However, they will eventually go. These products are also stronger. Therefore, less tested and might be less tested. And how it's clearly might not hurt.
All right. Let's see. Now, somebody who hasn't spoken yet. I'm pro. You can stand up and you tell them all the holes in their arguments. Right? I mean, it's obvious that they didn't really think about this, right? They should really concentrate better. So somebody else. And start. Yeah, I should let them first off, All right. Don, you've heard this stuff twice. It's just BS at this point. Come back. Next. Somebody who hasn't spoken yet. You got 2 minutes. All right. We've got 2 more rounds. We're going to do these. These next ones are 1-minute rounds. This next round, new speaker if you have one. What you want to do this time is you've made and countered your opponent's arguments. You want to summarize why you won. Okay? So this is, and these are the next two rounds. This round, pro and con are going to both go summarizing why they won, what their cases were, and then the very final round, every team is going to stand up and tell me the most salient point that they felt that they made. Okay, we're going to use that for what's called the final focus. Okay? So you got 1 minute. Summarize your position. Pro.
You guys mentioned the architect student who's on couple of academics in America, and I think that's a clear point of like people deciding and companies deciding how innovations into progress, right? And when for-profit entities get to control their proprietary code, they get to control how those innovations go into the future and what use cases people are going to apply, which means that interesting technologies that could do wonders in lots of humanitarian and
following the structure?
I have them,
I'm just talking. I was just looking over.
yeah, no, I told them they didn't have to follow the structure, but I wanted them, you know, kind of
No, they're having
communicating
a
different
good
ideas, yeah.
conversation in there. I was reading through
Yeah.
it. I hadn't heard of. I think this was. I think Liam's point I hadn't seen before.
You know, that's actually, yeah, that's unique.
I've never seen like the forceful creativity angle.
Yeah, yeah, forced all right, Pro, or Con. We don't want to give Pro too many chances. Con, you have a minute. Yeah, no, thank you. That's exactly what I should have asked you to do that. Now I'm looking like brilliant, and I just got let you. Yeah. Yeah, nice. Yeah. You know, so the one year I did it on, if something cool happens, yes. But I did it on, MongoDB.
I remember that.
Yeah. Yeah, that was my favorite one, quite honestly.
Are we still doing the Mambo unit?
Yeah, until I have, yeah. We are unless I figure out how to replace it with something like CouchDB. So if you want to work on something, give me some slides for CouchDB. Or any other one, yeah, we can even go SQL, like, jump to SQL. Yeah, there are open ones. Yeah. You know, so that would be fine as well, but I just haven't, I just run from one semester to the next. You know, it's not. You get the old stuff work as hard. Okay, we're now on final focus, I think, right? So what we're gonna do this time is, hopefully everybody has at least one speaker. If you don't get to speak this time, we will find something for you to speak about. I want you to type in, by the way, the people who aren't here today are quarantine people. They had a nice discussion in a debate channel that I threw up. And there were a couple of points there that I'd actually never seen before. So, and I'm listening here, I heard some points. I wasn't able to listen everywhere, although I kind of kept ear out there and ear out here. There were some really good points you guys made. So the first time I did this, I forgot to let everybody know ahead of time, which was kind of fun. This time I at least gave you guys 12 hours worth of warning. I thought that was pretty nice of me. So we're going to go around the room, one group at a time. Just when I point you, just stand up and tell us your most salient, what side you were on first. I guess that's probably important, and your most salient point. Okay? You guys want a minute to talk amongst your team? We don't have a lot of minutes, but we'll take a minute to talk amongst our team. If you guys want to type in your most salient point, that would be reasonable too. But I kind of like, Liam had a really good, I had never seen that point made, the forced Darwinism. I thought that was kind of cool and kind of unique. But all of these points are really good. You guys did a good job. If you want to just post your most salient point, that would be cool as well. I think that's a good way to kind of end this up. And then we will get back in just a few minutes. All right, you guys ready? I know that wasn't much time, but we're running out of any time. So, go.
Okay, so you were Con.
Con.
And you said that like the best reason is because in open source a lot of people contribute from all different like areas of the world, all different
structured. Cool. Pro.
Yeah, so we are the pro team. Our point advocating the best for OSS was that open source software has more public visibility. Therefore, there's more eyes on the project, which results in more code scrutiny, and that code scrutiny would in turn produce higher quality.
Excellent. Higher quality code due to distributed bug control. Records.
So we were pro, and one of our points was that open source software allows for more security, compatibility, and wider adoption compared to proprietary.
Wider adoption, better security, and
Compatibility.
Open source people have to work together. Good job.
We were con, and I guess our biggest thing was pretty much like organization, as she said, was pretty much you could have specific teams for each feature and functionality, which allows for a more, I guess, focused approach, and you have better software at the end of that, more efficient.
So you know where you're going and you can drive it to get there. Cool. Right here, you guys.
So we were on, our biggest point was, based on the example of the article that we read about, where the author of Colors and Baker Library trashed it and destroyed out the process, stuff like that.
Open source is more likely to be trashed when the guy gets mad because no one's offering a six-figure salary. Absolutely, we've seen that at least once. That was such a bad thing to do. Throw one. Next.
So we were also con.
Where's my pros?
These are pros. The pros are taking up the background.
Yeah.
So I think our greatest point was the fact that if you have someone who is very skilled but does not have social mobility, it is much better for them to work on proprietary than for open source, because open source is typically packaged. It does not generate wealth, especially at the beginning, whereas proprietary software is something that any person with enough skill and enough patience would be able to make money from.
Easier business case. You don't have to compete with your own code. Right? Is that
Yeah,
okay?
basically, yeah.
Good. Guys, you guys are two groups, right? Okay, this one and that one.
So we were saying, one of the benefits of open source is being able to be passionate about the code. Like if you're working a 9-to-5 job, you only care about the code as much as like get the job done. But if you're willing to work on an open source project, then you probably have a lot of interest in that project. And in that, you're going to be pushing bug changes and adding new features, and that's going to drive independence and your passion in that code is going to drive up more quality.
Okay, that was a really evil statement you said.
Why?
Basically what you said is open source developers don't have a life. No, a very good point. Good point. But you're right. If you're driven by a passion drive, then you are probably not doing 8 hours a day.
Along the same vein, since open source is free, everyone who enjoys the same thing most likely will come and congregate there. So their ideas and their passion, sometimes they might argue, but they all want the best product.
All right. Everybody working together to achieve the same goal because they all share the same values and view. All right, guys. I didn't finish up the slides. Mostly those are just examples of these things that you can look at. You can use them for references. We may hit them quickly, maybe especially the IPython notebook, the Jupyter notebook on Friday during lab. But other than that, you guys are free to go. Very good debate. By the way, read the Discord channel for the COVID people, the quarantine people. They had some really interesting discussion as well. So take a look at that. Thank you all. I will see if I can get wrapped. See you later. Sir.
I know I could have asked it later, but I was wondering now. So I might want to do a solo project for Arco.
Okay.
So what's the process for
For Arcos?
Yeah.
So you'll have to follow all the procedures as if you were a project lead. So you'll have to write a proposal,
Okay, I did that.
submit it, and submit your team, which will be you.
Okay, so
Okay?
I mean,
We'll go over that stuff today, but that's, basically you're the project lead.
yeah, because I was asking now because I might have some this today. So why would
Okay, but we'll be posting, I'm gonna try to do this same thing for that, and we'll be posting everything. But yeah, that's basically the process.
Okay.
Okay?
All right.
What's your name? I'm sorry. Kevin.
Yes.
Last name?
Cruz.
Kevin Cruz. Just, I'm trying to,
Remember.
this is better than the little blips of largely turned off cameras. I'm not sure that I will learn everybody's names, but we will try.
Yeah, but
Kevin
yeah,
Cruz.
Yes.
I will not get it right next time, but we'll. That's the replacement for Mongo, so that should be pretty close.
Yeah, I've got some experience with AWS.
Okay, actually, because I would like to do this one, but every time I get there, just getting the old one to work Hi. Ah. Was it fun? Hey, Hunter. Hey, you didn't take any slides, or you don't want to take any slides? You did? Okay, never mind. Forget that. I don't know. I